Hello viewers, today I, Dr. Prashant Badgujar, lecturer in electronics, Government Polytechnic Ahmednagar, will tell you about the basics of PLC components. Okay, so what we are going to see in this lecture, our learning objectives are, after this lecture, students will be able to understand process of PLC scanning cycle. Then students will be able to describe meaning of PLC scan rate. You will be able to understand importance of redundancy while using a PLC. You will be able to select appropriate PLC for required application. And finally, you will be able to find various factors to be considered while installing the PLC. So first one is the scanning cycle. What is the scanning cycle? It is a process in which program is scanned by the PLC. Okay, so it means whenever PLC is connected in automated system, we apply the inputs, or inputs are sensed by the sensors whose output is given to the input module of the PLC. Okay, so just consider this block diagram. So inputs we are giving it to the input module, the switch. Okay, so what is the process by which these inputs are read and the uh, output is calculated? Okay, so from reading input, calculating the uh, calculating the output based on the program, and giving output to the output module, which is again will be given to the actuator. Okay, so this entire process from input to the output is called as a scanning cycle. Okay, so the definition of it is a process in which program is scanned by the PLC, or it is a time required by PLC by reading input, processing the program, and giving output through the communication module. So these are two definitions of the scanning cycle. So it mainly consists of the four stages. First one is read input stage, second one is the execute program stage, third one is the diagnosis and communication stage, and fourth one is the update status state. We'll see what are these four stages in brief. So in first stage, PLC will read the input. So before reading input in this stage, firstly PLC will check the its hardware and software for any fault. Okay, so it will check for itself, so that there should not be any hardware change, or there should not be the software malfunctioning. Okay, so this is called as self scan test, which is happening in the read input stage. Okay, so after this, if PLC will find hardware is okay and software is also okay, at that time read input stage will begin. If there is a no problem, then the inputs are scanned and data is stored in the temporary memory, that is RAM. Okay, so this is the input scan. It check the status from input devices and the IO memory. Okay, so whenever we will switch on these switches, the signal will be arrived from the sensor to the input module. Okay, and the status of input, whether input has arrived or not, will be stored in this IO memory, or input output memory of the CPU. Okay, so this process will happen in the input scan. Okay, so next one is the execute program. Okay, so what is this execute program stage? What CPU will do, it will scan for the IO memory. Okay, so it will not directly take the input from the input module. It will only read the status of IO memory. If input is arrived, logic 0 or logic 1, logic 0 means input is not arrived, logic 1 is input is arrived. Okay, so which input at which IO, at which number of input the input is arrived, will be read by the CPU, and based on this digital 0 1 status, the CPU will process the program which is which was burned by the person in the PLC. Okay, so this is the program scan or execute program stage, in which the program will be executed and it will update result into IO memory. Okay, so as it is shown, it will read the IO memory status, it will process these inputs, and it will update the output memory. Okay, so status of this output memory will be read by the output module in the next stage. Okay, so it will, in this program scan stage, we will just read input memory status, we will execute the program, and we will give the output status in the output memory. Okay, so in this stage, CPU will read the data stored in the temporary memory, and it will execute the saved program on this data. Okay, the program is scanned rung by rung from left to right and top to bottom. This is called as the program scan. Okay, so this is the pattern of scanning the program. So this is the ladder diagram which we have programmed into the PLC. So PLC will start scanning from this side, from left to right. Okay, so this is the input relay, this is the output relay. Okay, so based on this, the input will be read by the input memory. So based on the input, the program will be executed, and the status of output memory will be stored in the output memory. Okay, so this is from left to right, and again the control will come back to the second ladder. The second this ladder will be executed, rung will be executed, and the output of the second rung will be stored in the output memory. It will again come back to the left side. Okay, so from left to right and top to bottom. So in this zigzag way, the program of PLC will be executed. Okay, so this is the correct horizontal scanning order, but we think that it is executed in the vertical manner. So this is totally wrong, and this scan pattern is the totally right. It is in the zigzag way, left to right and the top to the bottom. Okay, then third stage is diagnosis and the communication. So once CPU perform execution of the program, CPU will perform internal diagnosis and the communication work. Okay, so in this process, output are carried to the temporary memory of the output, used directly sent to the output card, which is used to send directly to the output card. Okay, so this memory is output memory is updated in this diagnosis and communication, and PLC will again check for the diagnose itself whether the outputs are calculated are fine or not, whether output hardware is okay or not. Likewise, it will do the diagnosis. Okay, and last stage is the update output stage. Okay, so it reads updates the previous value with the new value. Okay, so these output memory status will be communicated to the output module, and previous outputs are null and new outputs are overridden in the output module, and based on the output status in the output memory, the output module will do the actuation. It will turn on lamp, fan, or any kind of thing. Okay, so output module will take care of it, of the conversion of signal from one form to the another. So in output status, the output memory status is communicated to the output module. Okay, so these are the four stages involved in the scanning cycle: read input, execute program, diagnosis and communication, and fourth one is the output module. Okay, one more thing in this scanning cycle is the scanning cycle of PLC depend on the capability of the CPU. More faster CPU you will select, the more faster will be the scanning cycle. It means if the scanning cycle is very fast, then as soon as you will give input, CPU will calculate output, and within few millisecond, microsecond, you will get the output. But if the CPU will be very slow, then you will get some seconds or minutes to calculate the output. Okay, it is also dependent on the configuration of input and outputs, length and complexity of the program, and availability of additional functions like timer, counter, instruction set, and the configuration of the PLC. Okay, so these are the factors on which the scanning cycle is mostly dependent. Okay, next one is the next definition is the speed of execution or the scan rate. So it is the speed at which PLC scans the memory and execute the program. Okay, so more if the time of scanning this memory is very less, then the scan rate is very higher, and we can execute program very fastly. Okay, so ideally scan rate or the speed of execution of PLC should be infinite, but it is not possible. So we should select CPU with the higher speed of execution. So PLC, as we know that PLC scan is a continuous and sequential process. It will continuously scan for input. If input is arrived, it will calculate the it will execute the program and calculate the output. So it is a continuous process and sequential process. Okay, so from left to right, and again in zigzag manner. Okay, so one scan is the time period between one input output update to the next input output update. Okay, so once we have given one input, the program is executed and the output is calculated. So this is a totally one cycle. So from one cycle, so whenever one input is arrived and one output is calculated, this specific time we can call it as a one scan. Okay, so scan time is the time taken by PLC to get one input or output update to the next, from first to the from beginning of first to the beginning of the second. So this is the time is called as the scan time of the PLC. Okay, so usually the scan time is in the milliseconds. So scan cycle is, as I have told you, it depends upon capability of CPU, configuration of IOs, length and complexity of the program, availability of additional functions like timer, counter, instruction set, and the configuration of the PLC. Next thing is the redundancy. So redundancy means we can say it is a redundant, which is not useful. Okay, so whenever we work in the industry, so let's suppose that our first PLC which we are using for the automation, it will become fail. So what have we have to do? We'll go to the maintenance person, we will call him, we will take down this PLC, and by that time, if the PLC will not get repaired, at that time our production will get hampered. Okay, and it will be the huge loss for the industry. Okay, so what the industry will do, it will add some another PLC in parallel with the first PLC. So as you can see in this diagram, this is the active CPU of the PLC, and in parallel to this we will add one more PLC or the CPU, which is called as the backup CPU. Okay, so if this first CPU will stop functioning, then at that time we don't have to wait for the maintenance purpose or for the repairing time. Okay, so in this case we will bypass the connection to this backup CPU, and on this backup CPU the industry or automation will work. Okay, so it is given to the some externalized. Okay, so this is the parallel mechanism. If this will not work, then backup CPU will work, and whenever this active CPU will get repaired, we will again switch back to the first configuration. Okay, so this kind of mechanism or extra mechanism which is added to decrease the chances of total failure, it's called as the redundancy of the PLC. Okay, so for what purpose we are using this? It is used to provide minimum device failure and minimum errors. It will help to increase the productivity of my plant. It will also ensure the safety of the production and the process. Okay, so for this purpose we are using the redundancy. So there are two types of the redundancy in the PLC. First one is the cold redundancy. So what is the cold redundancy? It is a non-critical process where time is not a priority but human intervention is acceptable. Okay, so time is not important in this case, and we can go there and manually do certain kind of work. We can manually bypass the connection. Okay, so this kind of activities are uh, can be seen in the cold redundancy. As name suggests, it is a cold, so time is not the priority and human intervention is acceptable. Exactly opposite to this, there is a warm redundancy. So in this, when time and response to the failure is more important but not critical, when time and the response to the failure is more important but not critical, warm redundancy strategy may suffice if temporary outage is acceptable. Okay, so there are different types of redundancy or the components of this PLC redundancy. I mean, in every component we can see the redundancy. If we are using a backup CPU along with active CPU, then it is called as the CPU redundancy. In case of CPU failure, the standby CPU takes place the control of the plant. There could be a power supply redundancy. In case of power supply failure, the standby power supply take the control of the situation. Okay, the redundancy can be of the communication redundancy. Multiple communication channels are provided to take care of the communication network failure. Okay, and redundancy can be of the IO redundancy. Multiple IOs channels are provided to care of the IO failures. Okay, so means these are unnecessary components, but we are additionally mounting it for the safety or the continuous production of the my uh, in my process. Okay, so as you it is means in exceptional case only we are having certain benefits of this redundancy. It will be a very costly for us to attach the additional components in the parallel. Okay, but it will not hamper the production if we will go for the redundancy. So we have to decide what we have to do and what we have to not. Okay, next point is the selection of PLC. So how on what points we will select the PLC? First thing, we have to see our requirement. What is the input and output we are going to be required in future? If my plant or my process will be expanded, at that time we have to check whether IO of PLC can be increased or not. Okay, so what is the current memory of the PLC? What is the CPU and its speed? Okay, electrical requirement, various communication requirement, how complex is the software of the PLC, how frequently we need a operator interface, in what physical environment we are using this PLC, and whether the maintenance and availability of particular PLC is there in market or not. Okay, so these points we have to see while selecting the PLC. And lastly, While doing a PLC installation, what we have to. So, while doing PLC installation, we must take various precautions. User has to insert correct module in the proper locations and verify the type of module and the slot address. Okay, so there are various input output cards. The digital input card should be placed in the rack of digital input only. Okay, it should not be interfaced with the analog input. Okay, so this kind of precaution we have to take. Each terminal in the module is then wired to the field device according to the its termination address. Okay, second is the care is the uh, while doing a wiring, and we should follow is standard procedures. Okay, so while doing the wiring, we must check the correct size and gauge of the wire. Okay, so how much voltage or current the wire is carrying, we should consider this thing into the mind. Okay, so for very higher voltage, we should use the thicker wires or wire with the higher or the strong insulation. Okay, so we have to check the specification and the current handling capacity of the wires. Then what wiring procedure we can follow? We can follow certain color coding of the supply terminal, like red is for the live terminal, black is for the ground terminal. Okay, blue is for the DC, white is for the common, red is for the AC. Likewise, we can use a color coding in doing the wiring. Then third one is the software installation. How complex is the software? What cares does it need? Whether software will be installed on my PC or not. Okay, so these kind of things we have to follow while installing the PLC. And last one is the special precautions. So what kind of special precaution we have to take? So some field devices wiring connection need a special attentions. So these field devices can be having some small leakage current within themselves. Okay, so we should firstly check those field devices whether those are having some leakage current or not, and based on that we should install some our IO module. uh, Generally proximity switch is a leaky device. Okay, so if we are using a proximity switches, then we have to firstly check those switches and then install those switches. Properly shielded cables is used for control lines to protect the low voltage level signals from electrostatics and the magnetic coupling. Okay, so these kind of shielding cables we should use so that wherever there is a stray uh, uh, electrostatic voltage, that will be grounded. Okay, so these are a few special precautions which we should take while installing the PLC.